Hi friends, welcome to GMK Tutorials. Today we are going to discussing unit number 5, that is digital systems modeling in uh, DST by using Verilog, right? So in this, digital system means generally we up to now we have some idea about what is meant by combinational circuit, what is meant by sequential circuit. Combinational circuits means that which produces the output based on the input signal without depends on the previous data. So here previous data means that it is a past history. Past history means which depends on the previous values, previous output values. So that is simply we know that this is a combinational circuit. But when you go for a sequential circuits, obviously these sequential circuits also depends on the previous values. That is nothing but a depends on the previous outputs, right? So it is a very basic part if you are going to designing any real-time system. But if you go for the exactly in the real-time applications, obviously it is not a separate ports, it is a combination. If you are taking a one complex system, that complex system means that obviously which depends on it is a combination of complex system means that it is a combination of both combinational circuits as well as sequential circuits. So that's why within a single hardware it is not possible to develop whole complex system. So for that purpose, this complex system can be divided into two parts, that is nothing but data path, and second one is nothing but a control path. So here data path means that which consists of some functional blocks, or maybe it consisting of some functional units to perform all the competitions. Like if you are taking some examples, buses, registers, multipliers, adders, subtractors, counters, and all other functional blocks. In data path, lot of hardware is there, but we are not mentioned how we are going to use that hardware in the application. So that is the problem. So for that purpose, again one path is came into the picture, that is nothing but control path, where control path is nothing but it's like some finite state mission which produces some control signals to the data path to perform the some operation in a sequential manner. So control, the name itself represent control path. This control path controls the operations in the data path with the help of some functional blocks. So obviously in response to the control signals, various operations can be carried out by the data path. It also takes some input from the data path to know the status of the information. Suppose if you are performing lot of operations in the data path, but we need to, if you are controlling the system means basically you have to know some about that information status, where we are going to process, how much time it takes, whether the process is going to be completed or not. These kind of the information is obviously required. So for that purpose, control path also takes the input from the data path, right? So let us see a small example. In this small example, just we have to perform the addition of two numbers. Let us see here. So a is equal to b plus c, a is equal to b plus c, and d is equal to a minus c. Suppose if you want to performing this addition and subtraction operation, obviously here I have a four variables here. Just if you are observing a, b, c, and d. So if you are performing some operations in any digital electronics or maybe digital systems, obviously you have to store that operation, you have to store the data first of all. Basically you know guys are very well, if you want to store the data in the any digital system, obviously it requires some flip-flops. Flip-flop stores the only one bit of information, but if you are storing a Multi-bit information means that obviously we need a group of flip-flops. That group of flip-flops are basically, we know that it's a register, right? So I will call A, B, C and our register of the range from 0 to 15. That means it can store up to 16 bit. So let us see, first of all, if you want to performing B plus C operation, first of all you have to load the data, right? So that can be load B signal. At the same time you have to load the data in load C also. After that, that data can be given to the adder. This performs the addition operation, that resultant given to the A. That means whenever the this load signal is activated, at that time only the output of the adder is loaded into the register A. At the same time, the second operation is nothing but D minus C. D is equal to A minus C. Obviously, the output of the adder is loaded into the load A signal. At the same time, we can directly take the output of the C, and this can be given to the subtractor to perform the subtraction. That is nothing but D is equal to here A minus C, right? So this is generally called as the data path. Okay, so here some controlling signals is nothing but, if you want to load the data in a load yes register, obviously we have to activate the load signal. So that is nothing but control signal. At the same time, if you are loading the data, that is nothing but subtraction of A minus B, A minus C, that value can be loaded in the C register, means just we have to activate the load signal, then only it is loaded into the corresponding D register. This is generally called as a control path. So that is the basic difference between control path and data bus. So this is just a state diagram. S1 is load A, for S2 is for load B. Suppose, okay, so this is one topic. Next one is nothing but multiplication, right? Multiplication by repeated addition. Repeated addition. So this is a very important topic, multiplication by repeated addition. So generally in our school and days we have some basic idea, right? So generally multiplication means that 4 into 3 is equal to 12. This is all about in our early schooling stage, right? But our scenario is just we have to perform the multiplication operation by just only addition. That means suppose if you are going to performing 4 3s are 12, right? So this is nothing but actual value, but this multiplication can be performed just you have to, this by adding only one number you have to get this result of 12. That is nothing but just 4 plus 4, 4 plus 4. That means repeated addition. But if you are performing some repeated addition, you can get the multiplication result. But there is some question mark in each and every student mind. How many times I have to add that number? So for that purpose, we have to take one control signal. Okay, that is nothing but, let us see here, 4 is the number if you are considering where 3 is the control. Okay, so by taking this 3 times, if you are adding a 4 to the 3 times, so obviously we can get 4, right? At the same time, if you are taking a, suppose I will take 15, 5 3s are 15, right? That means if you are adding 3 times the same number, we can obviously get a 15 is the result, right? Suppose if you are taking add is initially 5, so 5 plus 5, 5, 10. So again if you are adding a 5, then we can get a total of 15. So this scenario can be represented in the form of a one flow chart. Let us see here. So here initially just we have to start the system. After that, if you are performing the multiplication of two numbers, obviously first of all we have to read that numbers, whether it is A or B. First of all you have to read that. So for that purpose, read the values of A and B, and P is equal 0 means that P is nothing but product. That means our resultant value can be considered as a product that can be represented with a letter P. Okay. At the same time, so the resultant, that means after adding that result, that can be stored in the register P. So for that purpose, initially P is equal to 0. That means if any value is stored in the previous register, that means if any data is present in the register P, we have to clear that one. So for that purpose, P is equal to 0. At the same time, P is equal to 0. Initially, P is 0, right? So 0 plus 4, we can get P is equal to 4, right? So after that, B is equal to B minus 1. That means whatever the signal we are taking, 3 is a control signal. First of all, 3 can be decremented by 1. We can get as the value of 2. So now we have to check that value. B value is equal to 0, then you have to come out from the loop. If B is not equal to 0, then you have to add number A, whatever the data stored in the register A, that can be added to the product value. Okay, that can be, this is a product of, that means whatever the previous added value, you have to add that number. So initially P is equal 4, right? Now initially P is equal 4. So P is equal 4. Again we have to add A value. So from this, so P is equal to 4 plus 4, then we can get 8. Now you have to decrement it by, initial previously our B value is equal to, now it is decremented by 1. So B is not equal to 0, then you have to again perform the addition. Therefore now P is equal to 8. 8 plus 4, then we can get a result of 12, right? Now then we will come to here, we have to check the value of that status actual, right? So previously, now B value is equal to 1. Now B value is decremented by 1. Previously B value is equal to 1. Now B value is decremented, so B value is equal to 0. So when the B is equal to 0, then you have to stop the process. So that means by adding of 3 times, we can get the multiplication of that number. So that can be shown in our, so this is a control signal. So this is a data path for that one. So here data path means just completely here data in means so by this if you are providing the data to the register A and register B, obviously we have to supply the data. So for that purpose, data input act as the external input to store the data in the register A and register B whenever the corresponding register load signals are activated. When load A signal is activated, then only data is loaded in the register A. At the same time, load P means data is loaded in the P register whenever the load signal is activated. So clear P means previously is there any value in the stored in the P register that can be cleared with the help of a clear signal, that is nothing but clear P. So B is nothing but, obviously in our previous example, just we have to take the controller, it is decremented by 1. So for that purpose, this B value can be acts as a counter. How many times I have to add the value to that total resultant number. So for that purpose, we have to count whether it is equal to 0 or, so for that purpose it can be treated as a down counter, because of obviously every time it can be decremented by 1 after completion of the one loop, right? So this is just a data path representation, how data is loaded in the register A, and initially P value is 0, so 0 plus P, that resultant value is again stored in the register P for simultaneous for adding the previous number results. So this can be carried out up to the B value is equal to 0. When the B value is equal to 0, then we will come out from the situation, right? So that is nothing but data path. So this is a block diagrammatic representation for data path as well as a control path, where control path is nothing but we have a 3 signals, that is nothing but data input, start operation, then operation. Then data path we are connected to the 5 signals, like load A for loading the data in register A, load B for data loading in the register B, load P for data load in the register P, clear P for clearing purpose, decrement for B value is for counting purpose, and equal to is the status information. So for that purpose, here connection is from data path to control path, right? So previously whatever we have one diagram is that a diagram can be represented in the form of a some detailed information. Let us see control path here. So let us see here. So initially start the data, so that can be represented as state as S0, and the data is loaded in the register A. So for that purpose, A is equal to data in. At the same time, data is loaded in the register B, therefore B is equal to data in. At the same time, we have to clear the register P also at the same time. So P is equal to Z means here P is equal to Z means it is a result of adder output, okay? previous adder output can be represented as z. So whatever the previous data, that z value is stored in the register b. So b is equal to b minus 1 means that obviously that b value is decremented by one value. If the b value is equal to 0, then we have to come out from the situation. If b is not equal to 0, then perform the same addition for repeated value. So p is equal to z, so p is equal to p plus a. So this value is repeated for all up to the, if b value is not equal to 0, okay, not equal to 0. If b value is equal to, b value is not equal to 0, then up to that you have to perform the addition. If b is equal to 0, then you will come out from the situation or loop. So that is nothing but it is a state diagram for S0 for storing stage, S1 for loading the data in register, S2 for loading the data in register S2, and S3 for controlling counting purpose as well as a checking purpose. If not equal to 0, then perform the same loop. If is equal to 0, then you will come out from the situation. So this is a state diagram, right? So this is all about multiplication by a repeated addition, right?